Okay, so we're going to start this lesson off. Whenever you're working with geometry or any type of math, we really want to know the goal, okay? So the goal here is to meet this standard. So you'll be able to kind of get a feel for what the state requires of you whenever you're taking these EOCs. Sometimes we'll meet the standard dead on, sometimes we'll only partially meet it. So standard here says, find measurements among points within the coordinate plane. Use points from the coordinate plane to find the coordinates of a midpoint of a line segment and the distance between the endpoints of a line segment. And then the second part of the standard says, find the point on a directed line segment between two given points that partitions the segment in a given ratio. Okay, so over here to the right, you'll see some formulas. And we're going to be using these formulas in today's lesson. So I hope that helps. Section 1.2 is measuring segments. So we're going to start out by talking about the difference between equal versus congruent. Okay, so ST, when it has a line above it like that, right, there's no double arrows. This is called a line segment. So it has two endpoints. And so this is just talking about the entire segment. So ST, and then a line between it. So it just means the segment connecting those two. Whenever you see the same letters defining this segment, but without the line across, it's talking about the measure. It wants to know what that measurement is, okay? So we want to know the distance from -4 to 8. So there's a few ways you can do this. You can think of counting by twos from -4 up to 8. So 2, 4, 6, 8, 10, 12. Or you can think of the final value, right, over here, minus the initial value. So we know it's 12, or you can think of it as 8 minus a -4, which is 12, okay? So down here, it says AB is equal to 4 centimeters and BC is equal to 4 centimeters. So what this is saying is that the measure of AB, is equal to the measure of BC. That's what that's saying, okay? So that's what equal means. Congruent means that the two sides are the same size, okay? And it may not give you a measure. You may have to figure out that measure. But it's given to you that here, triangle ABC is isosceles. By definition, what an isosceles triangle is that the two sides, right, these two sides here are congruent, and the two base angles are congruent, okay? So it means we may not have measured the value, but we know that they're the same size, okay? A midpoint of a segment is the point that divides a segment into two congruent pieces. It says A is the midpoint of CT. So just to show you what this looks like, I'm going to say CT, that's my segment. The midpoint is pretty intuitive. It's the point that's right halfway between the two. So A is the midpoint of CT, that's what that looks like. Down here it says segment bisector, a point line array that splits or divides a segment into two congruent pieces. Okay? So it says KE, which is a ray, is the segment bisector of the segment JO. So I'm going to draw JO first. The first point that it talks about, K, is going to be your midpoint. and it's extending on somewhere. So it could extend on this direction, that direction, or down here somewhere, but it just extending on forever. So E is right there. Okay, so KE is the segment bisector. So that means these two pieces are congruent and these two pieces are congruent. That's what that little line means, and that's what these angles mean, right? Angle, the one's dashed through it, means it's equal to this measure. These two slashes mean that these two sides are congruent. Okay? Given, it says O is the midpoint of DG. It says find DG. Well, if O is the midpoint, we know that the two sides, the two parts of this line segment are congruent. So what we have is DO equals, the measure of DO equals the measure of OG. Okay? Over here, it says that DO is also equal to this algebraic expression, 6x minus 7. And then it says OG is equal to this algebraic expression, 5x plus 1. So what we can do is we can use some of those algebra tools to solve this equation out. I can plug in 6x minus 7 or substitute it in for DO. So I can use 6x minus 7 equals OG, which is 5x plus 1. And from here, I can solve the equation. So I'm going to isolate the variable terms, get them on one side, so subtract 5x. So I get x minus 7 equals 1. Then I want to get rid of this negative 7, so I'm going to add 7 to both sides of the equation. So x equals 8. Okay, so I'm going to splice this video together. I had to talk to somebody. Okay, so x equals 8. So what's nice about this is once we have the x equals 8, we can solve the rest of the equation. All we have to do is pick either DO or OG to plug 8 back into. And what that's going to give us, it's going to give us a segment of DO and OG. So let's go ahead and do that. So I'm going to start with DO. DO is equal to 6x minus 7. Okay? But since we have x equals 8, now I can evaluate what the length of DO is. So I'm going to have 6 times 8 minus 7. 8 times 6 will be 48 minus 7, which gives 41. So what we have here is that the length of DO is 41 units. They didn't specify whether it was centimeters, inches, or whatever. It just tells us that the value of it is 41. So if we measured it with their standard of measurement, it's 41 units. But that's only the length from D. So that's only this length here. Okay? What they want to know is the length of DG. They want to know the entire length. But since we know that O is the midpoint of DG, and we know that DO is 41 units, we also know that OG is 41 units. Hey. So all I have to do is add those two links up, and I'll have the entire measure of DG. So DG is equal to 41 plus 41. So this is from DO, and this is from OG, okay? So that's just the length of those two segments, which is 82 units. So hopefully that gives you a little bit of a refresher on how to do this. So when we're doing coordinate geometry, there's a few ways to do it. Sometimes your problems are relatively easy. You can kind of see where the midpoint would be. And your brain automatically kind of does this for you. So the first point to graph is negative 5, 3. So I'm going to go 1, 2, 3, 4, 5. Negative 5 along the x-axis. And then up 3. 1, 2, 3. Plot that. And then negative 1, 3 is going to be left 1, up 3. So the segment here extends from there to there. And the midpoint of AB is what we're looking for. So if you can kind of see, AB is 4 units long. So 1, 2, 3, 4. So your brain can kind of see the distance of AB to be 4. We want to find the midpoint. So since it's a straight segment, halfway across is going to give us the midpoint. I'm going to call that midpoint M. So right there, 2 over. And I'm going to use the coordinate to talk about the midpoint AB. So the midpoint is going to be 1, 2, 3, negative 3, 1, 2, 3 up. So negative 3, comma 3 is the midpoint. So it's relatively easy, I'm not saying perfectly easy, but relatively easy to see if you have a straight segment, either horizontally or vertically, where the midpoint would be. The not so easy method is going to be when the points are all over the place. So the first segment over here, they're giving us a C, so it's going to be negative 6, negative 5, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So that's point C. The second point they're going to give us is D, which is 7, 3. So 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3. So that's D. I'm going to kind of extend this over. And so what we want to know is we want to know the midpoint of CD and the distance of CD. So notice the difference, right? Here you could see what it is really easily. Over here, it's going to be a little more difficult unless I have a ruler to see what that measurement is going to be. And even then, it may not be the unit that we want, right? Because that ruler would measure in inches. We want to know the unit that's being used for this XY axis. So it's going to be a little more difficult to do this one. So that's where our standard comes into play. That's what's important about knowing your standards. So let's switch over to those. There they are. Over here, what's nice is they give us the distance formula and the midpoint formula, okay? And these are going to be universal for the XY plane. In this geometry course. So the first one we're going to do is the midpoint formula. So I'm going to write this in that sheet. So over here, the midpoint formula is going to be a coordinate. So it's going to be M equals x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay? For the distance formula, it's going to be the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay? So what we want to do is we want to calculate the midpoint of CD using that formula and the distance formula of CD using that formula. So if you run out of room on this sheet, that's okay. I can switch, so use a different sheet if you have to. I'm actually going to do this. This is x1, that acts as x1, and this acts as y1 in the formula. And then for the second point, I've got 7, 3. So that acts as x2 and y2. Okay? So what I've got is I want to use the midpoint formula to find that coordinate. We're going to see how accurate this is. So we've got x1 plus x2 divided by 2. So what we're doing is we're adding the two x values from both coordinates and then dividing by 2. And then for the y coordinate, it's going to be y1 plus y2 divided by 2. So in this example, x1 is negative 6, so I've got negative 6 plus x2, which is 7, all over 2. And then for the y-coordinate, I've got negative 5 plus 3 divided by 2. So I've got negative 6 plus 7, which is 1 over 2, which is a half. So I've got 1/2 is the first coordinate, the x-coordinate of the midpoint. And then negative 5 plus 3 is going to be negative 2. So negative 2 divided by positive 2 is negative 1. Okay? So I'm going to show you how accurate this is. So we've got the midpoint is 1/2 negative 1. I use that formula. If you need to go back and pause the video, you can. It's negative 1/2, 1. No, other way around, right? Make sure. Check my work. Positive 1/2, negative 1. My mistake. Positive 1/2, negative 1. So if I look over here, if I go along the x-axis, 1/2, and go down 1, right there is the midpoint. Okay? So you can kind of see how accurate that is, and it divides the two segments into two congruent parts. So it kind of splits them into two individual sections. Next thing we're going to know is the distance of CD. So we're going to use those same formulas, all right? Use those same coordinates, but they're different formulas. So the distance formula, right, is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So x2 is 7. So I'm going to start to plug some of this in. I've got the square root of 7 minus negative 6 for x1 over here squared plus y2, which is 3, minus y1, which is negative 5 squared. So that's all underneath the radical. So order of operations says that I do parentheses first. I want to do what's inside the grouping symbols. So 7 minus a negative 6 is going to be 7 plus 6. So in the next line, I've got 7 minus a negative 6 becomes 13 to the power of 2, plus 3 minus a negative 5 is going to be, right, keep change, 8 squared. And then for the rest of that, let's say I don't know what 13 squared is. So I'm going to do, we know that 8 squared is 64, hopefully. And even if we don't, we can type that into the calculator. 13 squared, let's say I don't know that off the top of my head. I can come over to my calculator. 13 power of 2, enter, 169. Okay? So 169 plus 64. Use my calculator again. And I actually want to take the square root of those two. So second square root, 169 plus 64. And it's going to give me 15.26. So what that tells me is that if I come over here, if I measured the distance from C to D, let me make sure it doesn't round up. Yeah, it rounds down. If I measured the distance from C to D, from right here to right there, it's going to be 15.26. Okay? And that's just the units, so each one of those blocks is 1 unit. Questions on that? So where we left off was that this distance of CD is 15.26 units, which comes from all of this work here. So this is 15.26 units. And we were on another example of finding the midpoint and the distance of a segment. So the first thing we're going to do is we're going to plot these coordinates. So -6, 4. So left 1, 2, 3, 4, 5, 6, up 4. And then for the second point, I'm going to go right 5, 1, 2, 3, 4, 5, down 2. I'm going to connect these two segments. Connect these 2 points with a segment, that is. Okay, so we want to find the midpoint of those 2 points. So what I'm going to do is I'm going to go back and kind of work this out on OneNote so you can see. So I've got -6, 4 is my first point. So I'm going to call this x1 and this y1 just for the formula. And then my second point is 5, -2. So it's going to be x2, y2. So I want to find the midpoint of ME, which is the midpoint of these 2 points. So we're going to use the midpoint formula. So M is equal to x1 plus x2 over 2 for the first coordinate. And then the y coordinate is going to be y1 plus y2 all over 2. So I want to do this calculation. So x1 is -6, x2 is 5, so -6, the next line, -6 plus 5 over 2. And then y1 plus y2 is going to be 4 plus -2 over 2. So -6 plus 5 is -1 divided by 2, so it's going to be -1/2. And the next one is going to be 4 plus a -2 or 4 minus 2. So 4 plus a -2 is going to be 2. 2 divided by 2 is 1. So -1/2, 1. So if I head back to that sheet, we know the midpoint now, and we can plot it. So I'm going to go left 1/2 and up 1. So -1/2, 1. So if I look over here, I want to go left. Let me zoom in here. Oop, I broke it. Okay, there we go. Left 1/2, up 1. Right there, right about there is the midpoint. Call it M. No, I can't call it M because that's already used. We'll call it P then. P. Okay. So this segment is congruent to this segment. And the next thing we want to know is we want to know the distance of ME. So we're going to go back to OneNote and do that calculation. So the distance formula doesn't change, so it's something you probably need to memorize, or at least have written on a note card somewhere, is going to be x2 minus x1 squared plus y2 minus y1 squared. So I want to plug these values in and break this calculation down. So x2 over here says it's 5. So in this first parentheses, I've got 5 minus, and then x1 is -6. So 5 minus a -6 squared. Quantity squared. So remember to keep those signs straight. You're subtracting, but if you subtract a negative, it's going to be positive. y2 is -2. And then y1 is 4, so -2 minus 4 squared with a plus sign in between those two. So we're going to break this down. 5 minus a negative 6 is going to be positive 11. So I've got 11 squared plus negative 6 squared. Well, 11 squared is 121. But whenever I square a negative, this trips a lot of students up. When I want to show you two different things, because I don't want you to come back to me later and be confused on this. If you type negative 6 to the power of 2 in your calculator, what your calculator is thinking is you are only squaring the thing immediately to the left. So that includes the negative. That does not include the negative. So if you type this into your calculator, it's not the same thing as typing parentheses around that negative 6. What it's saying is you're multiplying negative 1 by 6 squared. So you're going to get back a negative. So that's negative 36. So whenever you square a negative in the calculator, get in the habit of putting parentheses around it. That tells the calculator you're squaring the negative 2. Anytime you have an exponent that's modifying something like this, it means multiply it by itself. That's what exponents are. They're repeated multiplication of the same value. So if I'm going to multiply negative 6 by negative 6, let me show what I'm saying. In this calculation, we already did 121 plus negative 6 times negative 6. That's what that means. A negative times a negative is going to be a positive. So I've got square root of 121 plus 36. So just be aware, whenever you square a negative, it becomes positive, as long as that parentheses is the square term is actually modifying the negative. Okay? So we've got 157 is the square root. That's a hard root to take without a calculator. So I'm going to use the calculator. Square root of 157 is 12.529. So I'm going to round up to 12.53. I generally like to do 2 decimal places, so to the hundredths place. So 12.53 units. That's the distance of ME. And with that, we're going to call it a day. Should be good enough to get us through the week. We'll go ahead and get started on some other things and get us ahead.